We're having this Bernoulli equation. You can see here we're having y to the power 2, and we say n is not equal to 0 and n is not equal to 1. Here n is equal to 2. So this is our Bernoulli equation. Our standard Bernoulli equation was dy by dx plus pxy is equal to qx into y to the power n. And we said n is not equal to 0 and n is not equal to 1. So we can just see it and say this is a Bernoulli equation. So what we do, we just multiply, we make this coefficient 1, remove this y factor from here. So we get here, multiply y to the power minus 2, we get here y to the power minus 2, dy by dx plus sine x into y to the power minus 2 is equal to sine x into y to the power 2 y to the power minus 2. We simplify this one, and simplifying this we get here y to the power minus 2 dy by dx, we get here plus sine x y to the power minus 1 into sine x. So here again we can find our w. Our w is y to the power minus 1. As I said, we have two ways of finding w. One is we can take this coefficient immediately and put equal to w. I will say our w is equal to y to the power 1 minus n. And we take n equal to, this becomes y to the power n. Find dy by dx, dw by dx, because this was transformation. So dw by dx is equal to minus 1 dy by dx into y to the power minus 2. So here we want to bring here minus 1. So multiply this equation by minus 1. I get minus y to the power minus 2 dy by dx minus here, because multiply minus 1, we get here sine of x into y to the power minus 1, and then multiply minus, we get here sine of x. Now here, now in position that we make the substitution, we substitute the value of y to the power minus 1 and substitute the value of dy by dx y to the power minus 2. If I rewrite that one, that's much better. If I write in the same form, we get here this equal to y to the power minus 2, we're having y to the power minus 2 into dy by dx. So we make substitution of this one and we'll get the new equation. Our new equation is, here we get dw by dx plus, not plus, we have minus sign, we plus here minus sine of x into w is equal to minus sine of x. So this was standard form, first order linear differential equation. We want to solve this one. This is our first order linear differential equation. We write the integrating factor, multiply the integrating factor and find our solution. So here our integrating factor will be integrating factor to solve the first order linear differential equation. Mu of x is equal to e to the power integral p of x is minus sine x into dx. We take minus sine out, we get e to the power minus sine x dx is equal to e to the power cosine x. Integral of sine x is minus cosine x, and minus is cancelled with the minus to get e to the power minus cosine x. I can write my solution. My solution will be d by dx of integrating factor e to the power cosine x into w, and that's our variable. We have changed our variable from y to w by using transformation. Integrating factor e to the power cosine x into q of x, that's sine x. Now integrate both the sides, we get here e to the power cosine x w is equal to integral of e to the power cosine x into minus sine x dx. Now again we use these substitutions. We take here z equal to cosine x. What's my dz? My dz is equal to minus, my dz is equal to minus sine x dx. So what will get? We get here e to the power z dz is equal to e to the power z. So I can rewrite my solution. My solution will be equal to e to the power cosine x w is equal to e to the power cosine x. We can add here the integrated factor. So we can write here is equal plus c is the integrated factor. So I make this coefficient 1 divided by e to the power cosine x. So get here w is equal to e to the power cosine x is 1 plus c over e to the power cosine x. So I can rewrite this one, more simplified form. I can write here w is equal to 1 plus c e to the power minus cosine x. What's my w? My w, we have just taken this one. This is my w. My w is y to the power 1. So my w is y to the power minus 1. I say 1 upon y. So I write here my solution. 1 upon y is equal to 1 plus c e to the power minus cosine x. This is my general solution for my differential equation. And this equation was my Bernoulli equation. And we solve this one. This is Bernoulli because here y was power 2 is a nonlinear differential equation. So we make this coefficient 1 multiplied by e to the power minus, remove y from here. So then we get here the equation, which is transform this equation to first under linear differential equation, and then we get the integrative factor. We write the standard solution form and then simplify it, integrate it, and we get the solution.